Morning students, welcome to the Science 1 class. Today we are going to learn about acceleration and equations of motion. Now let us learn about acceleration in detail. We learned that the velocity of an object can be changed by changing its speed or its direction of motion, or both. In either case, the body is said to be acceleration. Gives an idea how quickly velocity of a body is changes. We experience acceleration many times in our day-to-day life activities. For example, let a train start from a rest station. When it starts moving, its velocity increases, and after a certain time interval, it attains a constant velocity. As the next station approaches, its velocity gradually decreases and finally becomes zero at station B. This rate of change of velocity of an object is called acceleration. Here we can say that the term acceleration not only applies to increasing velocity but also to decrease in velocity. The decrease in speed of the body moves away from initial position is called deceleration. Deceleration can also be called the negative acceleration. As per the definition, the formula of acceleration of the body is shown on the screen. If the velocity of an object changes from the initial value u to the final value v in time t, then the acceleration a is v minus u by t. This kind of motion is known as accelerated motion. The acceleration is taken to be positive if it is in the direction of velocity and negative when it is opposite to the direction of velocity. Acceleration is also a vector and is directed along the direction of change in velocity. The SI unit of acceleration is meter per second square. If an object travels in a straight line and its velocity increases or decreases by equal amounts in equal intervals of time, then the acceleration of the object is said to be uniform. The motion of a free falling body in an example of uniformly accelerated motion. On the other hand, an object can travel with non-uniform acceleration if its velocity changes at non-uniform rate. Of example, if a bus traveling along a straight road increases speed by unequal amounts in equal intervals of time, then the bus is said to be moving with non-uniform acceleration. Now let us derive the equation of uniform accelerated motion. Consider the motion of an object along a straight line with constant acceleration. Then the acceleration of the object is shown on the screen. Let u be the velocity at the time t equal to 0 and v be the velocity at the time t and s be the displacement covered by the body during time t. Therefore, the uniform acceleration is shown on the screen. Acceleration is equal to v minus u by t. Then a into t is equal to v minus u. At is equal to v minus u. That is u plus at is equal to v. Consider it as equation 1. Since the acceleration of the body is constant, hence the average velocity is equal to v plus u by 2. But we know average velocity is displacement by time taken, so we can write it as v plus u by t is equal to s divided by t. Consider it as equation number 2. We get the following equations by solving the equation 1 and 2. Here we get the equation ut plus half at squared is equal to s. Consider it as equation number 3. By solving equation 1 and 3, we get the following equations. Finally, we get the equation v squared minus u squared is equal to 2as. Consider it is equation number 4. The equations of uniform accelerated motion are shown on the screen. If the speed of an object increases, the direction of velocity and acceleration on one and the same. If the speed of the object decreases, the direction of velocity and acceleration are in opposite direction. In such case, a certain instant speed becomes 0. If there exists an acceleration of body at a point becomes 0 for an instant, then the body returns in the direction of acceleration and moves continuously like in the case. Thrown velocity up into the air. Now let us study a few important points that ought to be remembered when using the equations of motion. The following points are to be remembered while using the equations of motion. Now, let's see equations of motion. Let us see the equations of motion by graphical method. The motion of a body moving with uniform acceleration can be described with the help of these equations called equations of motion. The equations of motions are v is equal to u plus at, s equal to ut plus half at squared, v squared minus u squared is equal to 2as. Equation for velocity time relation. V is equal to u plus at. Consider a velocity time graph for a body moving with the uniform acceleration a, with initial velocity of the body is u. At a and it reaches, find the velocity v at b in time t. Draw the perpendicular lines BC and BE from point B to the time velocity axis. So, the initial velocity is only a final velocity. Is BC and time interval is OC. Now, draw a line and parallel to OC, we observe that BC is equals to BD plus DC, which equals to BD plus DA. Substituting BC equals to and A equals to U, then we get V equals to BD. Plus U implies to BD equals to V minus U. Acceleration equals to change in velocity by A equals to BD by AD. That equals to BD by OC, which equals to V minus U by T. Implies to AT is equal to V minus U, implies V is equal to U plus AT. Equations for position time relation. S is equal to ut plus half at squared. Consider a velocity time graph for a body moving with uniform acceleration A traveling a distance as in time t. The distance traveled by the object between the points A, B and its area or ABC, which is trapezium. That implies the two as equal to area OABC. Implies it is equal to area of rectangle OADC and area of triangle ABD. That implies 2AS is equal to OA into OC plus half AD into BD. Substituting OA is equal to U, OC is equal to AD is equal to T, and BD is equal to V minus U, which equals to AT. Therefore, we get is equals to U. S is equal to UT plus half AT into AT. That implies 2S is equal to UT plus half AT squared. Third equation. Equation for position velocity relation. V squared minus U squared is equal to 2AS. Consider a velocity time graph for a body moving with uniform acceleration traveling a distance s in time t. The distance traveled by the object between the points A and B is the area OABC, which is a trapezium. That implies to S is equal to area of the trapezium OABC is equal to OA plus BC into OC divided by 2. Substituting OA is equal to U, BC is equal to V, and OC is equal to T. We get S is equal to U plus V into T divided by 2. From velocity time relation, T is equal to V minus U by A. Therefore, S is equal to U plus V into V minus U divided by 2A, which equals to V squared minus U squared is equal to 2AS. That's all for today's class. Thank you, students. Have a good day.